Okay, now what we're doing today is just adding, subtracting, multiplying, dividing expressions or functions to create a brand new function. So I'll be giving you two functions, f and g, and of those two f and g functions, you have to come up with another function, which is going to be f plus g. Do we see that, yay or nay? I did have that on last night's homework a little bit, but tonight it's going to be nothing but that. Okay. Now, with that said, tell me, what is f? F is defined to be 2x plus 1. What is g? X squared plus 2x minus 1. Now, I'm putting parentheses around both of these. Why am I putting parentheses around both of these? Because I need you to understand that they are two different functions, and if, like Trish just said, if there was a negative attached between these two, I would need to distribute that, and Alec gave us that yesterday. So I drop parentheses, and now I need to combine like terms. So what are my like terms here? So x squared comes over, that's gone. What's 2x's plus 2x's? 4x's. And what's 1 minus 1? Gone. So here is your f plus g function. Do we understand that? That's your final function. I created a new function by just simply adding two functions together. Do we understand that? Now what's my domain? Do I have a fraction? No. Do I have an even root? No. So do I have any restrictions? No, I do not. So therefore, this is going to be my lovely little function, my domain. Now, I'm changing the function. Get over it. I changed the function. See, this is the part where if you listen to the video, you can pause me and you can easily do that, right? There's no pause.
We can pause right now.
Okay. Now I'm going to do another function, and that function is going to be this time f minus g of x. So what is f? Minus what is g? And do I need the parentheses?
Yes.
Why? Excellent. Distributing that negative changes the signs on all three of those terms in the g function. Now can I combine like terms? Yep, negative x squared. Now what's 2x and negative 2x? Cancel out. What's 1 plus 3? 4. Domain. Are there any fractions? Are there any even roots? So what's my domain? The domain of f minus g of x is going to be x is an element of the reals. Do we understand that, yes or no? Okay, well now I'm going to take this a step further. And now I'm going to say, well, what is f minus g at 2? What is f minus g at 2? Did you see that before it was x, now it's 2? So what am I going to do? I'm going to plug in a 2, and I can go right from here. I can take a negative times 2 squared plus 4. And what is 2 squared? 4, but that negative hangs out. So what's negative 4 plus 4? 0. So what you're telling me is f minus g at 2 is the value 0. Do we understand that? Are we good? Mr. Bear, are you good? Okay, do we understand that part?
Wait, hold on. Go back to the why is
I picked 2 right out of there.
Why is negative on the outside now?
Because the negative is on the outside, it would be like negative 1 times x squared.
This is up.
Do we understand that?
You're not going back and doing it to the original, you're only doing it.
You may. You can go to the original.
You're going to do the same thing.
Yes, you will.
No, come here.
Let's do it so that everybody can see.
Well,
I need everyone to be quiet now. Yes.
How would you know the negative goes on the inside?
It was a negative 2.
If you are plugging and chugging in a negative number, then it would be a negative 2 quantity squared, which would be 4, but then you still have to multiply by negative 1. Okay? Okay? Now, you're telling me that you don't believe if I plug in and chug it at the beginning that you're going to get that answer? Okay, so you're saying if I come up here, that's so cheap. If I plug in a 2 here, that's going to give me 2 times 2 plus 1 minus 2 squared plus 2 times 2 minus 3. Do you see that? Well, what is 2 times 2? Plus 1 is? Minus 2 squared is 4 plus 4 minus 3. 4 plus 4 is 8. 8 minus 3 is 5. 5 minus 5 is 0. You distributed it, and you did not do order of operations correctly. Did you do order of operations? Please excuse my doing it. Now you have to parentheses first. And you did multiplication by distributing the negative. It wouldn't be wrong if you actually distributed correctly, but somewhere you screwed up. Okay, does that make sense? So I've showed you both methods, okay? Either plugging it at the very beginning, or calculating that plus g, simplifying it completely, and then plugging it in. Do we understand that? Yes or no?
Yeah.
Are we good? Okay, now I give you this function, and I'm changing this back to a 3. They yelled at me last period. Yeah, third period yelled at me. Really, they were really mean. They were really mean. I want that to be. It makes me happy. Okay. Now, same 2 functions that we had before, but this time I want to do what to them, you think? Multiply them. So now I'm going to do f times g of x. So that's going to be 2x plus 1, parentheses x squared plus 2x minus 3. Now, how do I multiply a binomial and a, what is that one? Trinomial. How do I do that? It's very simple.
Break it down.
Distribute each term. Very good. So I'm going to have 2x times x squared to give you 2x cubed. 2x times 2x gives you 4x squared. 2x times negative 3 gives you a negative 6x. Plus x squared plus 2x minus 3.
Here. 3%.
I'm breathing. I'm walking away.
Hold on.
The sooner I get out of your way, the better off you can copy.
Farther off.
I distributed the 2x, that's the red. The green is me distributing the 1. Everybody with me?
This is very long.
Now what do? See, isn't color coding great?
Add the,
Do that on a
add
chalkboard.
like terms.
Combine like terms. So I have 2x cubed, that's gone. How many x squared do I have? 5x squared. How many x's? And then minus 3. Do you see what I see? Way up on the map, or does it here? What's my domain? Why is the x is now the real? Why is there no restriction code?
Or no even root.
There's no fraction and no even root. I'm going to continue to ask that until it's so embedded in your brain that you have no choice but to remember whenever I say on the test, what is domain?
Yeah, but if there is a restriction, I don't know how to find it.
If you have a fraction, what's the restriction on a fraction? The denominator cannot be 0. If you have an even root, what's the restriction? The junk underneath the root has to be greater than or equal to 0 because you cannot take the square root of a negative number and be in a real number system.
Yes, I do.
Are you listening to me or are you
Yeah.
listening to me?
Somehow.
There, you wrote on it. We're distracted.
Same hair
You're
color.
female. That does not help. Now, moving on. I did f plus, f minus, f times. Now what am I doing? F divided by x, or g. Shh. Shh.
Okay.
Don't get angry.
Hey, what's that?
2x plus 1.
2x plus 1. What is g? X squared plus 2x minus 3. Now I need to simplify this. In order to simplify this, what must I do, Alex? Factor the denominator into two beautiful binomials. So I need factors of x squared. Can I split up evenly? X and x. I need factors of 3 that are going to be subtracted to give me a positive 2 plus 3 minus 1. Now, can I cancel anything out? No, because 2x plus 1 is one term, and that term cannot cancel out with the other two terms on the bottom of x plus 3 and x minus 1. So this is my little lovely f divided by g. So now I need to know my domain. Yay, nay? Do I have a fraction?
Yes.
Yes, I do. So do I have restrictions?
Yes.
What are my restrictions?
X plus 3 cannot equal 0, x minus 1.
X plus 3 cannot equal 0, and x minus 1 cannot equal 0. So therefore, x cannot be negative 3, and x cannot be positive 1. Put it in the real number system.
I get that right.
Do we understand that? Yes or no?
Yeah, you're a little bit me out.
Now, what if I wanted you to do what if I want you to do f times g of 3x?
So something like that can plug in everything to G first.
You're going to plug in first. You have to plug in both f and g.
So
That's f
3x
times
would
g.
go in for like x.
So the 3x, what's f times g? F is 2x plus 1, g is 3x minus 2. Well, what am I plugging in for x?
3x.
3x. So what I actually have going on here is 2 times 3x, and then 3 times 3x. Do we see what the x became there? Yes? Do we see what the x became? So what is 2 times 3? What is 3 times 3? And now you would actually FOIL. Do we all understand that?
Let's FOIL.
Let's FOIL?
Yeah.
First, 9 times x, 9 times 6 is 54x squared minus 12x plus 9x minus 2. Do I have any like terms? Yes, I do. And what are my x's? Give me a 3, and that is f times g of 3x. Do we all understand that, yes or no? We're good?
Yeah.
Excellent, because then the next thing we need to talk about is composition.
I don't like the free stuff. Just trust
Ball
me.
and goal.
Yes, just not chapter 1-5. Okay, now, composition. Oh, that's not my composition. Here's my composition.
Oh,
That's the wrong page. I had the wrong page.
My goodness.
Jeez.
The whole thing.
There's no
ridiculous.
love in here today. I mean, there is absolutely no love.
I'm serious. Look at you out there.
I had the wrong page. Man, you guys are going to burn me at the stake.
Yes.
Okay, now, composition is something we learned back in Algebra 2 also. Composition is whenever you plug in one function into another function. It's what we call a composite function. Do we all understand that? So f of g of x is equal to f parentheses g of x. They are exactly the same thing. They are read exactly the same way. Your brain needs to be able to understand that they are one and the same. It's a matter of, for example, Trisha's name is Trisha, but she'll answer to Trish sometimes, right? She's still the same person, okay? One is just more formal notation than the other one. Do we all understand that, yay or nay? Okay. Now, I give you f of x equals 3x minus 1, and g of x is equal to x squared plus 1. Now, what do I want you to do? I want to do f of g of x. Okay? Now, many of you do not like that little O in there. So, go ahead and replace it with a parenthesis. That's legal. Now, in mathematics, which way do we work? Left to right, and if we have parentheses, from the inside out, correct? So guess what? We have, now we have g of x. What is g of x defined to be? Since I know it, I'm going to drop it down in there. Do we understand that? Because I know it, correct? Now what does this say I need to do? I need to do f at the value x squared plus 1. So what is f of x defined to be? 3x minus 1. I'm replacing the x with what? So if I replace an x on the left-hand side with x squared plus 1, I have to replace the x on the right-hand side also. So that's going to be 3 parentheses x squared plus 1 minus 1. Do we see I replaced the x on the left-hand side with x squared plus 1, so I have to replace the x on the right-hand side with x squared plus 1. Yay, nay? We good? Not your first rodeo, you've all seen this before. So now, what is 3 times x squared? 3 times 1 is 3 minus 1 gives me a 2. This is f of g of x.
2 level 1 teachers think you remember everything.
Okay.
I want to see you flex. It's got to be like ridiculous.
What?
Like, you know, right on.
Whatever. Do we understand this? Are we good? Can I go?
No.
Hang on. What am I hanging on? We ready? Okay. Now, what do? I want to do g of f of x. G of f of x. Can I rewrite that? I can get rid of the little circle, right? And make that g parentheses f of x. What else do I know? I know that f of x is 3x minus 1, so I can plug in what I know it to be. Correct? And now what's this function telling me I have to do? I have to take my g of x function, which is x squared plus 1, and now I need to plug in that 3x minus 1 in for x. If I do that on the left-hand side, I also need to do that on the right-hand side. This g tells me which function I need to use, correct? So now I'm going to have 3x minus 1 squared plus 1. Do we see that, yes or no? The x squared now became the 3x minus 1 quantity squared. So what do I have to do?
What the whole thing gets squared?
Because it's x squared. And x became 3x minus 1 on the left, so the x on the right needs to turn into the 3x minus 1 also. So since it's squared, I need to write it down how many times? 2 times to give me 3x minus 1 times 3x minus 1 plus 1. And what do I need to do? FOIL it. 3 times 3 is 9x squared minus 3x plus 1 plus 1. CLT. Combined like terms gives me 9x squared minus 6x plus 2. This is g of f of x. we understand that?
I still think you can.
Sure.
Sorry. Now, what if I took this another step and I said I want to do g of f at 0? What if I said I wanted to do g of f at 0? I need to plug a 0 in for x. Well, here is my function, and I'm going to plug in a 0 every place I see an x. Do we understand that?
So you,
I want to do g of f at 0. Well, this is g of f, right?
So if it had a 0 in there the whole time, you still do all that same stuff you just did. You probably don't actually.
why, when of equals 5, you get 0 on 3?
Because that's not what they decided to do back in the day when all the dead people decided to go for dissertation.
Why? Because they didn't do a little job back then.
Yeah, so some things just never change.
So I can't change
Well,
this?
that's gone, and I'm left with 2. So what this means is g of f at 0. Did you see how I did a different notation this time? Because Booker likes this notation much better than he likes the other notation. Okay? That is doing evaluation. Now I have one more concept I want to teach you guys,
Oh,
That
form
proves-
state.
and that is prove
Oh, the one that I already broke down?
the one that you started to write down. See, it all comes back. It all comes back.
Oh,
You guys are whiny today.
You're just bad.
Oh my gosh. Okay. Now, I am giving you two functions, f of x being 2x plus 3 and g of x being 1/2 times the quantity x minus 3. Now, I want you to prove to me that those two composition functions, f of g of x and g of f of x, are equal to each other. How do you suppose that I prove that they are equal to each other? Well, you do each one. I need to do f of g of x. And then over yonder, I need to do g of f of x.
Yep.
Do we understand that? You have to do both. So, how do I go about doing that? Well, tell me, what is g of x?
but
What is g of x?
1/2.
Do we see that? And I'm plugging it into the function of f, and what is f defined to be?
whoa,
2x plus 3.
It's defined to be 2x plus 3, but every place I see an x, I need to plug in the 1/2 times the x minus 3. Do we all see that?
Wait, you need to put that in that?
So that's going to be 2, parenthesis, 1/2 times x minus 3, plus 3. My x became the 1/2 times x minus 3. Yay, it's ugly. It's cosmetically challenged, just like some of us, we are. We can't help it. There are days we're cosmetically challenged. What happens to the 2 and the 1/2? These cancel out, and I'm left with x minus 3 plus 3. Those cancel out, and I'm left with x. This is f of g of x. And it is equal to the value x.
You really have to do this.
Now I need to compare it to g of f of x. Yes? Well, what is f of x? What is f of x? So I'm doing g at the value of 2x plus 3. Correct? I'm calculating the function g at the value 2x plus 3. What is the function g? So every place I see an x, what am I going to do? So this is going to be 1/2 times 2x plus 3 minus 3, close parentheses. Do you see that, yes or no?
Keep the 3 on the inside.
So you
Yes.
just put that.
I put what was in the parentheses for the g, the 2x plus 3, in for the x in that g function.
Why don't you put parentheses after the first 3?
Because that's what x is. Okay, what happens to my 3's? They cancel out and I have 1/2 times 2x. What happens to my 2's? They cancel out and I'm left with x. And this is going to be g of f of x. Now look at them. Look at f of g of x and g of f of x. What can you conclude?
They're the same.
They're the same. So therefore, I proved that they are equal. And you know what else I proved?
That matters.
They are inverses. Do you remember back then in the day? We're coming up with inverses next, and I'm excited.
I don't get excited with math. I still.
Okay, now I have one more thing, just because it sounds like fun.
I put exclamation mark.
This function right here is a, you know what, I'll do this.
Yes.
You're breaking me. I didn't do it with my algebra, with my third period, so I'll do it.
My brain's already dead. And I have to learn more. After this model. So I'll turn that down.
Okay, I need everyone to be quiet, no talking still. I'm passing out your worksheet. Yes, I made a work, well,
I haven't been able to do what kind of.
Oh, fuck you.
Are you serious?
Okay, now for problems 1 and 2, are we listening? For numbers 1 and 2, find each of the following: f plus g, f minus g, f times g, f divided by g. So A, B, C, and D, you have to do all 4 of them, and then letter D, or I should say letter E, then says find the domain of f divided by g. So you only have to find the domain of the division. Do we understand problems 1 and 2?
Yeah.
Problems 3 through 6, I give you f of x and g of x. It says do f plus g at 1. Do f minus g at 2t. Turn it over. Do f times g at 2t squared. And do f divided by g at t plus 2. Do we understand this? 7 and 8, I want you to do the composition f of g of x and g of f of x. And then do f of g at 0. And lastly, 9 and 10, I want you to prove that f of g of x is equal to g of f of x. Any questions over what I just talked about?
We need to have some.
This is not that bad. T is just some random number that we can pick. It's a value. It's a placeholder. It represents x, but a different x.
That's what you should do.
Okay.
And it would be not equal to x.
It is not equal to x. It is a different value.